and welcome to the PCS Adventures Magnificent Makerspace webinar. We'll do a quick overview before we get started of the agenda today. I'm going to introduce Nikki and Michelle, who you see in front of you. They're going to dive into some best practices with STEM and how that relates to a makerspace. And then we'll do a little bit more specific practical examples of how Makerspace works in action using the PCS Adventures Lab as a Makerspace spotlight. So we have a lot of experience, as you've been reading our emails, 25 years of experience running makerspaces, and we've learned a lot in that time. So Nikki's going to share her examples of running this space. And then we'll dive right into some examples of parts and pieces that you can use to create your makerspace. What are the materials that you're going to need to be successful, and give you some examples of those. And then, as I said, a Q&A session at the end. So if you just type into that question pane, I will see all of those. I'll try to answer them in the panel as we go along if they're quick. If there are questions that I think everyone needs to hear, we'll save them for the end. And then if we don't get to any of your questions in the webinar today, I will have a record of everything you put in there. So we'll be happy to follow up with you afterwards if there's something that you want a little bit more feedback on. And so I'll let you know really fast here. Nikki is the girl with the glasses here on screen. And she is our director of lab here at the PCS Adventures Lab in Eagle, Boise. And then Michelle is our director of STEM development at PCS Adventures. She directs all of the curriculum development for PCS Adventures and has both of these women have a lot of experience teaching STEM, robotics, to a variety of ages and in a variety of settings. So we're really excited to have them with us today.
Thanks, Allie. We are both at PCS Adventures, and you can see we're here in our Eagle Lab. We've been doing STEM education for over 25 years. Obviously not me and Nikki ourselves, but the company has been around since it started in the garage of an Idaho educator. PCS actually stands for Pat's Computer School. And so back then, before STEM was just a part of a plant, he was still teaching students how to build, how to work on computers, how to do whatever it was the students were really interested in. And so our space looks a little bit different today, but the mission is still totally the same. How do we innovate in STEM? How do we get students really excited about learning? Yeah. And what does it take to do that? So we're really excited to talk with you today. It's been really cool to see STEM really take off as a movement along with the maker movement. Nikki and I were talking even since we were kids. I mean, there was some hands-on science, but there's such a push now to make STEM a way to make science and math hands-on and engaging for students.
Exactly.
And so we've seen in that there's also been this big push to really integrate this hands-on technology and engineering into topics like science and math that maybe appealed to some students, but we want to bring that as an experience to everybody that they can be excited in.
Right. Yep. I mean, I didn't have exposure as a kid to robotics and coding or anything like that, and now it's becoming more and more common, even in elementary schools, middle schools, that students are getting exposure and having successes with those topics. And so I think it sparks an interest, and that goes a really long way, as we'll talk about later.
Absolutely. And it's cool to see that people are now really taking STEM and starting to rethink, what does learning mean? What counts as learning? That it doesn't have to be just a test or just a bunch of facts, that it's learning if you're doing an experiment, if you're building something, if you're engaged in something creative. And so we really see that as a guiding philosophy for why STEM is a really natural fit for a makerspace.
Exactly.
And so as you're thinking about of all the things you could be doing with your students in your program, one of the biggest reasons for STEM is that it just opens so many career doors. I wish I had known about this when I was a high schooler looking for careers. If you look at the toughest jobs to fill in 2016, so many of them require students to have a strong background in STEM. And so the other part of it is that this is the list for 2016. Who knows what that list is going to look like when our students are graduating from high school. And so we don't want to train them to be home health aides or registered nurses in particular, because the job list when they're graduating will probably have jobs that don't even exist yet.
Exactly.
So how do we prepare them to have a broad set of skills, to be strong thinkers, to be innovators, to be really interested and engaged in STEM, so that whatever the jobs are out there, they're going to go on and be successful.
Right. We're more teaching them how to learn and how to adapt and
Yes.
to think logically rather than become an expert at, one type of coding or something like that.
Yeah, really this idea of 21st century skills. Can they communicate? Can they collaborate? And how do you transfer that then into these careers that are going to be available to them?
Right.
And so this really guides our philosophy of a makerspace, because we know from the research that our students are incredibly capable. The question is, are they inspired? Do they see themselves as the sort of person that's going to go into a STEM career? And so if you can, by the 8th grade, get a student to show an interest in any kind of STEM career, that's a more accurate predictor of whether or not they'll go on and get that degree and be successful than their math scores or their science scores. So it's not just about, do they have the knowledge, although that's important, but do they have an interest? Has something come and really grabbed them and made it personal, made it something that's their own?
Right. And we were talking about, it just takes one experience or one teacher reaching out to really spark that interest. And so you were talking to me earlier about that your one biology experience. You want to talk about that?
Yeah, so I was in high school, and like a lot of high schoolers, thought maybe I wanted to be a writer. I wasn't really sure. I did well in math and science classes. I didn't know math could lead to a career when I was in high school. But then I took a class on science research, and a friend and I, we programmed a device. It decoded chicken vocalizations. We went on to this national science fair, and it really did change the course of our lives. And I think for me, it was just the fact that people took us seriously. Like, people were actually interested in this device. It was a real world thing. And so for us, it really woke us up to, oh, this is something we could do, but I honestly just hadn't considered. So the mission really is, you want every student to have the chance to do that, to have that experience, be exposed to that. Maybe STEM is their thing, maybe it's not, but you want it to be an option for everybody.
Right, because they don't know what they're good at if they've never been exposed to it. And so exposing every student to at least one STEM concept, can really just be that, it can be that light bulb for them.
Totally. And tell me a little more, Nikki, how did you end up in STEM?
I didn't have any exposure to coding or robotics or anything like that in school. And it wasn't until I took a coding class in college, and I created basically Microsoft Word using Visual Basic. And I was just baffled that this whole world was out there, that you could create these magnificent things, and I had never done it. And suddenly I had this creation I was really proud of. And so that inspired me to take more coding classes in college. And then when I taught later on, and I taught more hands-on, in an outdoor school, I watched students who did hands-on projects who suddenly, I saw the light bulb go off. That suddenly this thing that they had learned in the classroom and could recite, the definition of, finally became relevant. And I haven't stopped doing STEM education since. I love it. So.
No, and I think what you said is so important, that it's something you're proud of, something you're invested in, something that's yours. When I taught robotics, I totally saw that too. Students that maybe never saw any real relevance to what we were doing in science class would be incredibly invested in this robot that they had built because they were on a team. It was part of this community. It was really powerful. And beyond just being proud, it gave them a space where they belonged. And I think that's the other part that's really important too, in that makerspace. And so Nikki will talk more about our Edventures lab here, but this is really the vision, is how do you inspire students to become innovators, to go on and be successful, and to see what's open to them? What are the opportunities that are out there? So as Allie introduced, Nikki has a ton of experience. Like she mentioned, she's worked in outdoor education, teaching hands-on STEM. She also went in the Peace Corps and taught in an all-girls school in Tanzania. And then we've been so lucky since then to have her here running our labs. You can see some of the students in our drone program on the screen. And so she has a huge wealth of knowledge to share. She's got a bunch of stories about our students, and then some best practices to share with you on what makes a really successful makerspace to bring this really powerful experience to your students.
Wonderful. Thanks, Michelle. I run several labs here in the Boise area. We're in our Eagle lab right now. And these labs are truly a makerspace. We cater to students 4th grade through 12th grade. And then we also run camps during holiday breaks, summer, Christmas, spring break for younger students. But what we've tried to create here is just a really positive, safe place for students to come after school or in the summer to be creative, to express themselves without, I guess, any judgment. And so a couple of things that we do here specifically is we have a really low student to instructor ratio. We usually do about a 1 to 4. No more than 4 students to 1 instructor, and that allows the student to really get great one-on-one time with instructors, pick their brains, and not feel like they're just a number in a classroom, right? And that allows us to create really great relationships with them. So then they come to class, they don't feel like they're just going to school. They feel like they're coming to spend time with their instructors who are also their friends.
Oh, and you've talked about for some students, it becomes a really great alternative space for students that maybe don't really see themselves fitting in so well at a traditional school, that this can be this totally different environment.
Exactly. So I've had, a mom tell me that coming to lab has been, they always come on Fridays. And the reason they do that is because her students are both on the spectrum, and they try so hard every day of the week to fit in a school. They try to be normal. They try to fit that mold. And it's exhausting to constantly be trying to be something you're not all day, trying to make friends and not be the weird kid. And so they would come every Friday, and this was their win for the week. It was a place where they could come to express themselves, to be creative, to make those jokes that they try to censor themselves from making at school. And it's just been a truly positive place for them to come and not feel like they have to fit the mold. There's no, our lab doesn't have any deadlines, right? It's a completely self-paced lab, and I'll talk more about the structure of our of our merit system that we have students go through, but it's completely self-paced. There's no deadlines. You don't have to wait for other students to learn. You get to go at your own pace, and you're also not rushed if you're a student that takes longer. And so it allowed them to be creative, to try things, to fail things, and there was no negative repercussion to that. And so it's been a really, I think, great space for a lot of those students who maybe don't fit the great traditional student role.
Well, and I think you really see students grow through that, right? I mean, you've gotten to see students come in at the very beginning of middle school and having that safe space to really grow into themselves.
Exactly.
Right?
Especially in
really
that
benefit.
transition time when
Yeah.
they're really trying to figure out who they are.
Yeah,
you know?
absolutely.
So, so a little bit more about how we, how our classes and things are structured in here. Students attend our Makerspace once a week for 75 minutes. And we start our class with a 10 to 15 minute what we call mini lesson. It's usually hands-on, and it is based on the theme of the month. So every month we have a theme, and we create 4 lessons based around that monthly theme. So for example, this month we're talking all about statics. So we'll talk about some of the fundamentals of statics. We talk about the relevancy of statics in our world. Where do we see it? Why is it important? Jobs and careers that use it.
Yeah,
and then we issue them challenges to see if they can go out and explore different concepts of statics and challenge themselves to build something related to statics. And then after that 15-minute mini lesson, then they're set free for 60 minutes to do really whatever they want. They get to choose in our program what they learn. It's not someone saying, this is the curriculum, this is what we're learning now. They say, robotics, that looks fun. They say, 3D printing, that looks fun, and they get to choose their path. Something else that's wonderful about our space is that we have students ages 9 through 17 in here, all working in the same environment. There's not a class for 9-year-olds, a class for 10-year-olds. They're all working side by side and learning from each other, which means they're all also working on different projects. And so one student might be working on the robot and looking at the student next to them and saying, when I'm done with this, I want to do that.
Yeah.
And so it's letting them kind of see where their interests are and chasing those.
Yeah, well, and what awesome role models, too. Do you see your older students kind of step into that role, too? Like, they know they're the senior students in lab?
And I think they really enjoy sharing that knowledge.
Yeah.
So oftentimes in our mini lesson, when we issue a challenge, sometimes they're group challenges, and those older students will always pair with a newer student to help them through that.
Yeah.
And so I think it's positive for both of them.
That's awesome.
Yeah. So the objectives in here, I think maybe some people watching are educators, right? And we're always used to writing a lesson plan, and we have to state the objective, and it has to be a measurable objective, and it has to be the student will do this thing. And we don't have that in lab. We don't really have a set objective. What we really focus on is what's on your screen right now, which is habits of mind. And the habits of mind, if you are familiar, what we say to students is that these are the skills you should have to be successful in the world. If we can practice these things every day, then we will be successful when we leave lab.
And how do students respond to that? I mean, do they really embrace it as this thing that they take on?
I think if you just say, here, the habits of mind, like, of course not. No student's going to read them and be like, yes, I understand all of these. But we use them daily when students do things in lab. We reference that. We're saying, hey, you know what? You just overcame that challenge and you were really persistent. And that's one of our habits of mind. So great job. Hey, you built this structure. We tried to put the rock on it, our 11-pound rock, and it crashed, but you took a responsible risk and no one got hurt, and I'm really glad that you did that. It's taking those actions that they do in lab and then giving them a concrete reason why they're being praised for it, especially some of our students on the spectrum who maybe don't understand social cues. They don't quite understand what actions are, socially normal and good and which ones aren't. And so if we give them a concrete example of why they're being praised for that action, then it solidifies that for them.
Well, and then for your instructors, we're all trying to give specific praise. This gives you, these are the things we're really trying to cultivate in our students, and then you're constantly looking for examples of those to build that up in your community.
Exactly. And it's all about how they face those issues. One of them that I love up there more than anything is finding humor, and listening with understanding and empathy. Those are ways that they interact with each other, and so some of those students are like, well, I don't know why you praised me for that. And I said, it's because of this, because you just failed. And then we laughed about it and we learned from it and we picked ourselves up from that and didn't let it crush us, right?
Yeah. And they're kind of like, oh, okay, I guess that is a good
Because
thing.
how often do they have a chance to fail? And we'll talk about that a little bit later. But, just that, oh, I failed. But we clap and we cheer, and it's actually a positive thing in here to fail. So
that's huge.
Yeah.
And we have to show you, this is the wall of the lab. The habits of mind are literally plastered on the wall right where students sit when they do that lesson every day.
Exactly.
So as you're going through with the habits of mind, do you feel like students respond really well to this idea of setting their own goals? I mean, that's so different than what they're used to doing. Does it sometimes kind of take a while for them to really embrace the open-ended of lab, or are they just ready to jump in?
Sometimes it's difficult, but what we do is we actually set goals with our students. So every few months, I sit down with each student during their class time and we look at their badge sheet. So maybe we should talk about a little bit how those badges work. We have an integrated merit badge system. It's kind of like a cross between the Boy Scout merit badges and a karate belt system. So it's represented in a pyramid, and every student starts out at a yellow level in whatever topic they choose. Maybe that's coding, maybe that's statics, maybe that's SketchUp. And that builds really the fundamentals of their knowledge of that topic. They're starting to learn, and they're issued these projects which are step-by-step, guiding them through how to use some of these skills, how to gain some of these skills. Then we issue them challenges. Can you use those skills? Can you put those skills to the test? Can you create this thing for us? And then at the very end, it culminates in a design project. And so the student then gets to say, okay, I know how to do these things. I'm comfortable doing these things. Can I integrate it maybe with some art, right, and get creative and build this bigger, magnificent thing? And so once a student completes all 5 of those stages, there's 2 projects, 2 challenges, and a design project, then they get to fill in their badge. And it's like a pyramid, so they have to have at least 2 yellows to build up and get an orange. And that orange will be in one of those topics that they've already done. So maybe it's robotics, and they said, oh, I loved robotics. I want to do more robotics. So then they move on to a deeper level of robotics in orange, and goes through 8 levels all the way up to black. So for that student who's very goal driven or needs to know what's coming next because they've been in school and they're used to that,
right,
the goals are a very tangible pathway for them. But what's great is they get to choose.
Yeah,
you know?
absolutely. And some of them need that structure. And the cool thing I've seen here in lab too is some students love that structure. They thrive on it. And other students are like, I don't want to do any of that. I want to do this thing.
Right.
And the awesome thing about you guys in lab is the answer is always yes, let's
Always.
do it. That sounds
Always.
awesome.
Letting the students really chase what they're interested in, regardless of, even regardless of if we have it in lab.
Yeah.
We had a student that say, I want to rebuild a computer. And I said, well, I don't have a broken computer to use. Do you have one? He said, yeah, I have one. So he brought it in. We fixed one of the very first generation MacBooks.
That's awesome.
Not only did we get it running, we put Windows on it. So now we have a working Windows laptop that's an original gen MacBook, you know, and we had to bring in soldering tools and we brought in things that weren't originally in lab, but we're never going to squish a child's dreams of creativity and learning, right? It's whatever it takes to bring that stuff in and make that learning happen and keep that, you know, keep that interest going, keep that spark going.
Right. Because how real world is that, right? I mean, we're so used to having this structure, but to just have a problem, say, I'm going to solve this, and to have your instructor say, I don't really know how, but I'll help you figure it out. I think that's really powerful for students to realize that sometimes their teachers don't know either, and that they can figure it out with them.
And that's something we really, really push in our lab space, is we say, you know what? I don't know the answer to that. And that's okay, because I'm willing to learn with you. Because I think so often in school, if you don't have the answer, then you're wrong. And if you don't have the answer, then you're scared.
Right.
And
so
I
you
think
don't want to be stupid.
Right. So opening up this space and this environment in here where I ask my other instructors questions, they ask me questions. Then students start to feel comfortable asking questions when they don't know the answer. And that's when learning can really take off.
Yeah.
Because they're not afraid of what they don't know anymore.
And, you know, I remember one class I was in, students came in and they were setting goals, and this was a super bright student, someone who's always really successful in school. And so the thing he chose was the thing he thought would be easiest. And so he chose that one first because he was new and he was scared, but he was obviously really bored. He wasn't that into it. And so you guys got him involved in a robot zombie building challenge.
Yes.
And he was super resistant at first because he didn't know what to do. But within a couple weeks, he had built a swimming zombie robot, and he was so proud of it and he was so into it. And he worked on that for a month.
Right.
And after that, but for him, you could tell he was a little hesitant. And to break that down, he got so invested in what he was working on. It was really cool to see.
It's a completely new way of learning for them. It's not, here's this concept, here's a worksheet, let's, practice it so that you can pass your test. It's a whole new way of learning and exploration and failing and trying things. And I think a lot of students are really scared to do that. They're hesitant of that, and that's just because of our school systems. We don't have time to practice and experiment and fail because we have standardized tests to pass. So this environment really opens up a whole new way of learning, which is so necessary when they get out into the real world.
Yeah.
No one says, okay, now that math class, use everything you learned in Algebra 1, and here's how you use it. It's going to be so integrated, and it's going to be, here's a problem, we need to fix it, we need to learn it hands-on.
Yeah.
So they're really getting great experience that way.
Yeah. And do you have the initiative? Is it something you personally care about and are going to start yourself, or is it something that the instructor always handed to you?
Exactly. It all comes from them. And sometimes students come in with really, really ambitious goals. And sometimes we have to go back to the habits of mind and talking about fundamentals, right? And like we had a student that came in and he said, I want to build a social robot. That is a great goal. Unfortunately, roboticists are still struggling to achieve that. So let's break it down. What do we need to get there? Let's learn a little bit about programming. Let's learn a little bit about static and dynamic building and gear trains so we can have moving arms and parts. And once we broke it down into all the components that were necessary to make that happen, he had a better concept of what it was going to take to get there. And then we started at the beginning. We started at yellow statics. So.
Yeah. And that really shows, your curriculum isn't the point. Right? I think in school, students see curriculum as the point of the class is to get through the curriculum. But it's there as a structure, as a resource. But if you have a student that's already had this spark and has that project, awesome. They're not a student that needs the structure of that curriculum. They're already where you're hoping to get the rest of your students.
Exactly.
And so I think it's really almost liberating as an educator to have a curriculum that you can use if it's helpful, but that you can totally throw it to the side and jump in with whatever a student's interested in.
Exactly.
It's like what you always want to do in your classroom, you can
Yes.
actually do it because there are no rules.
Exactly. All right, so a lab mentality. So we've referenced this makerspace specifically as a laboratory. We do call it PCS Adventures Lab. And the reason that we do that is I mean, for a couple of reasons. But it's really to set the tone of this space. When students walk in and we tell them it's a laboratory, there's kind of a sense of what that means already that's been instilled in them, right? The sense of respect, and that things can be dangerous, and that we need to be really respectful and focused and really conscious when we're in here. So students that we really emphasize that students have respect. They have respect for themselves. They have respect for the equipment that's here. They have respect for other students and their interests, as well as instructors. And that means sometimes putting pieces away, right? And making sure that the pieces are in the right places so that the next person who builds, they're in the right place for them. Along with that lab, that lab mentality, that lab culture, is also an emphasis on nomenclature and naming things. And that goes back to, even our habits of mind, right? Thinking and communicating with clarity and precision. If a student wants help finding a piece or a part or help fixing something, they need to be able to communicate that to us really clearly. And they can't just say, Miss Nikki, where's the red piece? The little red, we have, you can't see them in this picture. We have thousands, hundreds of thousands of pieces. I don't know which little red piece they're talking about. So they have to be able to start knowing what those pieces are called. And communicating really clearly. And that's a life skill, is communicating and collaborating with other people in a way that is understood across all the people in that group, especially in science, right? Science is across the world. That's why we have a standard unit of measurement, so that scientists can communicate with anyone and everyone collaborating on a project.
Totally. Now, your students probably come in knowing a whole range, right? Some are already going to know what a rivet and a gear is, and some have probably never heard those words before. So how do you kind of make it an equal playing field for everybody?
We go in, we kind of tell them how the pieces and parts are broken down, but the biggest thing we do is encourage them again to ask. And then not only ask us, but because we're constantly roaming around and busy and helping with projects, but asking their peers who have been here a really long time. And that really helps create that community. We encourage our students to talk to each other, ask each other questions about, and the easiest way to do that is, telling a new student, hey, you can ask the senior student where the pieces and parts are in lab, because it takes a really long time to learn. In fact, we're all still learning where pieces and parts are. And that creates this community in here. So a couple ways that we achieve that is we have students that attend once a week for 75 minutes, always during the same class. So, we hold class on, for example, on Tuesdays at 4 o'clock. And that's what works with their soccer schedule and their piano recitals and everything else. And so Tuesdays at 4 is when they come. Well, they're coming with 9 other students every Tuesday at 4 o'clock. And that helps them all know each other. They learn each other's names. They become friends. They start making those connections with these students who have the same similar interests in them. And that opens this space up for great conversations, communications, and they can really talk about things that maybe they don't talk about at school because it's weird or it's, none of their friends like the same things. But, we talk about dark matter, and we talk about video games and Star Wars
came out.
All those things that are socially maybe relevant, maybe some pop culture, but we always keep it positive. We keep it science and math related. And it allows them to really just express their interests. And so creating that community, that space where students feel safe and free to speak about those things, is huge, because sometimes at school that doesn't happen.
Well, and what about your instructors? You must really train them up, right, to really create that, because it doesn't just happen on its own. You guys really cultivate that sense of positive community.
We do. I have really wonderful instructors. I'm really fortunate to have a lot of Boise State University students with us. Some of them are studying gaming and multimedia. Some are studying structural engineering, electrical engineering, but they're just big nerds too. And so we really strive to be nerdy and geeky, positive role models for these students, and always making sure that when they come in here that they are safe and they are free to be who they want to be. And so my instructors are truly, truly wonderful at that, and students leave happy. And no one, we shut down if there's any negativity, it gets shut down immediately, because no student needs to feel that way in the space. That's not what the space is about. So, my instructors are wonderful, and we really just try to cultivate a big, safe, creative space in here.
It's awesome.
Yeah. These pictures are fun. So this is a really good example of creating a community that we do in our lab. So recently, just a few months ago, we held a robotics sleepover. And so we invited some of our students who had been with us a while. They had to achieve certain badge levels to be invited to this. But we had, I think it was 10 students in total, come for an overnight robotics challenge. So we came, obviously, if you can see in the picture, we gave them pizza and soda, and then we spent all night. We split them into 2 teams and issued them a challenge. The challenge was to build a crane, and then build a device that could hold a hard-boiled egg. It had to lift that egg device a meter and then drop it and have the egg not break.
That's awesome.
And it's a pretty intense challenge. It has so many pieces and parts. So you have the programming, you have the statics, you have the moving pieces, you have the gears. It was really, really quite involved. And so they had to split into teams. They had to each have a role. And these guys became best friends by the end of that night. They worked until 3 o'clock in the morning. Eventually, I had to shut it down, make them sleep for 3 or 4 hours, and wake them up again in the morning. And but what they created was magnificent. It was truly amazing. Both teams had working products.
It's amazing.
And alone, that would take a student probably 5 or 6 months to build in our program. And they accomplish it in just hours working together. So it really shows that when you create a positive environment for students, that they really will thrive and rise to any challenge that you give them.
Now, students mostly work on their own, but do you ever find that they end up collaborating on projects in
Yes,
lab? Totally.
yes, often. It is really self-paced, and it's self-geared, and they can work independently on whatever they choose. But so often they make friends. They make friends, and these friends have similar interests, and oftentimes they will work together, especially if it's a project similar to this, where they have where there's multiple components. So maybe you say, Michelle, I know you're really good at CAD. Do you think you could build me this thing, and we can 3D print it so I can use it in my movie?
Yeah.
You see collaborations like that happen all the time.
That's so cool.
So, and even between older and younger students, sometimes you'll ask, a 9-year-old isn't afraid to ask a 14-year-old to help them with a project, which is huge. You're not separated into grades. You're just a big community.
Yeah, it's like breaking down that hierarchy that they're so used to.
Exactly. All right, failure is awesome.
Yes, we got the big F up on the screen. This is a huge one for students. They're so used to getting graded, and no one wants to get the failing grade. And so I know this is a huge thing you guys focus on, is how do you break down that fear of failure and really get students to embrace it as something positive?
The biggest thing we do, again, is we train up our instructors to just be positive and encourage failure, encourage thinking outside the box, and often that means that failure is going to occur. We have failure occur almost on a daily basis when students are testing out their video game, when they're testing out whether their object is 3D printable, if they're testing their bridge, whatever it is. And whenever there's a failure, we cheer, we clap, we embrace it. And so it's not a scary thing. We also say when there's a failure in lab all the time, so students can see that they're not the only one failing. They see that every person around them is taking risks and thinking outside the box, and it doesn't always work. We have bin pieces, and sometimes you pull out a bin to grab a piece, and they just splatter on the floor. And we clap and cheer, and then every single person in lab goes and helps them put that bin back together.
That's so cool.
And so you have to create this space of where it's not scary to fail. It's not scary to ask questions. It's not scary to try something that's never been tried before, and know that that's okay. So
Do you see students taking bigger risks because of that? You know, once
Yes.
they get used to that, that's got to be really cool.
Yeah, especially when we say, you know what, build that bridge however you want, and we're going to test it. And whether it holds that rock or not, we're going to give you some credit for that, especially for that student if they're super motivated and goal-oriented and they have a goal of attaining that badge, they're not going to think outside the box because they just want to make something that meets the criteria to move on. And so you have to say, you know what, take a risk, take a leap. Don't worry about that badge. We will get you that badge. Don't worry about that. Go and do what you feel like doing.
Yeah.
And it's only then that you'll get those students to truly be creative and not be afraid to build a 5-meter tall tower, which totally happened. Did it hold the rock? No, it didn't, but it was magnificent, and they got credit for it. So,
And probably learned a ton. And probably, you're so right, wouldn't have done that if they knew, here's the minimum criteria, I'm going to get it done, check and move on.
they learned so much more by failing. Because then we sit there and we look at it. It's not a failure and then you take it apart. It's a failure that we then look at. Where was all your, compression and tension? Where did it fail? How could we have fixed it? And that's a learning opportunity that they won't forget. If they just build a cookie cutter bridge, they'll move on and probably didn't learn much. So.
Yeah, and it does take a lot of vulnerability to say, I really think this is going to work, and risk that it might not, and for that to be okay.
Right,
That's really
and
powerful.
instructors do it too. So every week we take a build hour.
Sweet.
So we come together as a collaborative team and we build and we do what the students are doing and we work through their badges too. And they see that. They see our projects. They're like, who built that? I'm like, me. They're like, it looks weird. I know. So you have to show that it's okay to try something different. And we try to exemplify that all the time.
That's so cool. Thank you so much, Nikki, for being here. Now you can see all the stuff that we have here in Lab. We really think a lot about what are the best manipulatives to really encourage this free experimentation. And this really is a question of how do you choose? Because right now there are so many awesome materials. We're always finding something new and thinking, oh, we should get that. Our kids would love that. But you really do have to think when you're investing, what's your kind of core set of materials that's going to last, that's going to let your students start out and not be scared, but then really grow and get to do these really complex projects.
Exactly.
So we want to share with you a couple of the pieces that we use here in Lab, and then that we've really then packaged to be able to share and sell to other makerspaces that want to bring in the same sort of experience for their students. And so it really does depend on how old your students are. And so these first ones here are especially for elementary. And so bricks are like the bread and butter of elementary building. Almost every student has had some experience with some kind of building brick like this. And so it's great. You dump these out in front of students and they're going to start building. I mean, it just comes completely naturally. They get how they work. They're not intimidated. And so we've built out our own bricks. They've got softer edges. They're a little bit stickier. They make less clatter when you dump them out, which all of us know if you've worked with kids in bricks. They also come in 2 different sets of colors. We felt like traditionally bricks come in primary colors, and so we wanted the full spectrum. So we've got turquoise, teal, pink, purple, all of our vibrant bricks that were developed as part of a Girls Can Build initiative. You can see some of the girls testing them out on the screen there to make sure that the bricks had the full range of colors for all the students as they're building. And then we package this with a bunch of different curriculums. So if you want to expose your students to technology concepts or science concepts, or just show them some basic building fundamentals so that they understand how the bricks work, and then have those tools when they say, I want to create a 6-foot tall tower, they can make one that's actually going to stand and not fall over and start building up their construction skills.
Right. I love bricks even at a young age to start teaching fractions. Right?
Yeah,
Bricks are
totally.
the perfect mechanism for showing, here's a hole, here's a 2x8. How many 2x4s can I fit in there? And so
You can teach everything.
You can teach everything. We have taught everything in lab using those bricks.
And we've taught everything from double helix and DNA and alleles down to fractions to storyboarding. One of our developers is an elementary teacher, and her husband is a high school calculus teacher. And he was trying to figure out, how am I going to teach this concept to my kids? And she said, I bet I could teach my 4th graders how to do that with bricks. And he said, no, no way. And she did. She went in, she used the brick, she made it hands-on, and her kids totally got it. So we really believe in bricks as a makerspace manipulative that totally crosses into science, math, really anything you want to teach, you can do it with bricks, and your students are going to love it.
Right. And we have a lot of curriculum out there, so don't think if you buy a pack of bricks, you just got to like
Figure it out.
figure it out. We have tons of curriculum that expands over many different concepts and topics that can be integrated into the classroom
Totally.
or to your makerspace.
Absolutely. So one thing we see a lot of our folks doing in makerspaces is maybe they have bricks, their students have worked with bricks, and so a really great one to pair with them are cubelets. So we have some of these here. They look at first like blocks. They snap together with magnets, so you can snap them in any different configuration. The cool thing is that the colors on the cubelets actually matter. So unlike bricks where you just have a bunch of different colors, on these, the color tells you what the cube does. So some of them, like this one here, have a sensor on them. So this one is sensing how much light is coming in. This one is a knob that can respond to the turn. And then other cubes are going to do things. So you might have a cube that has wheels, that shines a light. So when you attach this battery cube on here and turn it on, you have a set of cubes that are responding to inputs to create an output. And of course, the cool thing about that is that's a robot.
Exactly. It's a really great way to introduce the concept of robots can sense and they can think and then they act and they have input. And you can tie that back to senses, right? You know, they use sensors like we use our senses to gather data from our environment, and then they have a reaction to that. And so it's a really great way. We actually have, we've tied it into animals too, and how animals sense things and how robots sense things. And then what's really great is you have this piece on the back, which is a brick adapter. So I can put this on any side and then build a creation to make my robot that maybe my robot senses brightness and it stops moving when it gets into a dark place. We tie that into hibernation. So maybe then you want to make this robot look like an animal that hibernates. There's so many applications of these robots. And just seeing the students manipulate them and put them together in different orders and seeing how that changes the output, it's really magnificent to see. Those
just
light
to
bulbs
see
turn
them.
on.
Yes, to see them, because sometimes to us it seems like, oh, input, output, got it. But for a student to be able to put them together, to turn a knob and see a light turn on, to make that connection, it is really cool to see a student finally get like, oh, if I cover the sensor, the light's going to turn on. And if I take my hand off, it's going to go away. Like they've just understood robotics. They get it. And then it makes it not scary. You know, if you're talking about inputs and outputs and sensors, they're like, oh yeah, I know what that is. I get that. So I think that's really cool to see kids as young as kindergarten starting to build robots.
Exactly. And then Cubelets has also added a programming interface. Really similar to any of those block drag and drop coding programs that you might be using like code.org or Scratch to help control the input and output of these blocks. So then you can take a manipulative that they understand how they work and advance it, you know, so these aren't too too little kiddish, right, for even sixth grade. They can really level up with your students, and you could use the same manipulative with all of your elementary school students. Which is so important. You want something that's going to stretch, that you can really reach all your different students, no matter where they're at. It's not something new that comes in when they're older, right? It's something that they're familiar with and can continue that knowledge rather than being reset on a new manipulative every single year. Totally. And so we always start with bricks and cubelets for the younger students. And then it's really cool once they start to get into upper elementary to middle school. Here in lab, we use Fisher Technic. So this is the crane that Nikki was telling us about earlier from the sleepover. And all these same parts are included in one of our products called Discover Engineering. And there's so many things we love about Fisher. They're German made, as you can tell from the colors, but they include so many more than just basic building blocks. So with Fisher, you can have gears, you can have parts of a pulley, you can have struts and rivets to build structures. And the cool thing is even their basic building blocks have a pin and groove system, so you can build on all four sides. So unlike Legos where they just stick together like pancakes, you could put two together and then have builds coming out these sides, have builds coming out these sides. And so once students realize what's possible, they can really build a lot. I mean, even the 3D printer that we're giving away at the end of the webinar is completely built with Fisher Technic parts and is fully operational. Yeah, they're really, unlike Legos or Connects, they're really designed for engineering purposes.
Absolutely.
So you have X struts and I struts, and the X struts are 82.8 millimeters, you know, and it's because they've done their Pythagorean theorem and figure out that that's a commonly used hypotenuse, and it's
Yes.
it's really wonderful to do that applied mathematics with students and help them understand that. And I love Fisher Technic. I will never go back to anything else.
No, especially because you can combine Fisher Technic with our robotic system. So this is RIQ. He's the robot we developed at PCS. We use in our lab. He's based on an Arduino microcontroller. And then on top of that, we've built Cortex, this programming software that makes Arduino programming really easy. So you can see there on the tablet, it's visual, it's colorful. If students have done any kind of drag and drop programming before, it's familiar. What's cool about it is with the robotic system combined with the Fisher Technic manipulatives, once they get down, how do the motors work? How do the lights work? How do these basic mechanical inputs and how do the sensors work? They can really take that and apply it to anything.
Right. It's completely integrated. So the brain, which is our Arduino microcontroller, will hook into all of our Fisher Technic, right? So you can, just like that crane that you saw in the previous slide, it had a microcontroller on it that was telling the motors when to turn on, when to turn off. It was hooked into sensors. So you start taking all of these fundamentals that they've learned about statics and dynamics and gears, and you can integrate them in these really big culminating projects that students are so proud of.
I have to mention this one. Nikki had a student the other day literally build a wall climbing robot with brains, with pneumatic pieces, with suction cups, and it would literally crawl up the wall. He was so proud, and it was so cool.
It was spectacular.
They showed it to everybody, and it was totally done with these same basic manipulatives. So they're accessible enough for your new students, but can absolutely go deep enough for your most advanced students.
And I think if you look at Cortex, you might think, oh, that's really simplistic. And it is, especially it's great for new learners, but it can set states and variables and randomization and comparatives, and it can create a program as complex as you need it to.
Absolutely.
It's really robust. So
the other thing we include with all of our products is curriculum, and totally designed in this philosophy that Nikki was talking about, that this is going to have that series of projects that introduce skills, some basic challenges to get them to apply those skills and be successful, all building up to what do you want to do? What can you do with this? Let's be creative. The world is yours now that you've got those skills. What do you want to do with that? And so as your instructor, this really sets them free to be a coach, to be a mentor. You don't have to teach them how to do everything. You're there to help model all those skills, those habits of mind, and to really guide them through that emotional process of trying, failing, making it better. And so it really changes the dynamic of what those roles are between the instructor and the student. And then you have that curriculum there, so you're not spending all your time trying to figure out just how to make the robot work.
Right.
That's taken care of.
Right. In our Makerspace, in our lab, we are not teachers. We are instructors. We are guiding the learning process. We are not teaching, we're not teaching concepts or anything like that. We're more of, and it's hard when instructors first come on to understand what that role looks like, but
So this is just a quick snapshot. We talked about Discover Engineering, Discover Robotics and Programming. We have a whole line of these built out in that same curriculum style, so you can really mix and match these different titles to start building out your makerspace. So like Nikki talked about, when you set goals, students can choose, I want to work on robotics, or I want to work on CAD, I want to work on 3D printing. So you can really customize based on what your students are interested in. The last thing we want to put out there too is to always keep thinking too about what's going to work best for your students, because it's going to be different. And so what is it that's going to inspire them? And so typically the go-tos are engineering, racers, rockets, robots, but your makerspace could also include claymation. It could include movie making. It could include sewing. It could include, in Magic Bean, students build props out of bricks and put on theatrical productions.
Right.
And so making can totally include art. It definitely can include robots, but to not feel like it can't include some of these other things that your students may be really interested in.
Right. And I think is a lot of us know, oftentimes female students really like to dive into a story. And so allowing them to do that through these things, through movie making, through 3D printing jewelry, 3D printing props for movies, all those types of things, allowing them to think of makerspaces as not just like a place to build and a place to code, but a place to be expressive in however they see fit.
Right, because you want all students to feel like they can see themselves in their makerspace. And so definitely as you pay attention to your students, that'll really guide what you put in there, what products make sense.
Exactly.
So I know we have just a couple minutes left. We want to be sure we have time to answer any questions that have come up during the webinar before we give away the Fisher Technic 3D printer.
Yes, so definitely stay on the line. We'll be drawing, a random winner from our attendees to take home a 3D printer by Fisher Technic. That one that you see on the table to the right of Nikki is one that we have built here and used, and it's actually our preferred 3D printer to use. We've tested a lot of them, and this one has actually been the best. And it's really cool to actually just build it here. So there were a few questions that have been coming up. Feel free to type them into this box as well, and I will get to as many as I can. The first one that I wanted to bring up is, and I think you touched on it toward the end of that, but what is the kind of interest that you've seen from students in incorporating artistic or performance side of making, and how do you encourage that?
So we actually have a video productions badge in lab, and so each level goes through different skills needed in video production. We encourage students to do either stop motion or live action movies. So our claymation camp actually includes specifically a stop motion like camera, but it can also do live action, and we think it's great. It's collaborative. Students maybe take a break from the computer screen or the building to really just create a storyboard and imagine. And it's been I've seen really amazing movies come out of it. We also pair it sometimes with engineering. So we have like a zombie month where they make zombie movies, but in order to do that, they have to build a zombie. And so in the months prior to that, we do simple machines and basic mechanical actions, so they understand how to make different pieces move. So they can maybe get a crawling motion or a walking motion or something like that, and then incorporate that into movie making. And we could do better about incorporating more artistic things in lab. But again, you have to pick and choose what you're going to put in your makerspace at what time. And also 3D printing. 3D printing is also very artistic and creative, and that's paired with SketchUp, which is a CAD program. So we try, if we have more artistic students, to steer them toward those things that we think might be really enjoyable for them.
And I think one way you guys do that is in that intro lesson during Zombie Month, to do a really intentional job of highlighting, to make these movies, you need engineers, but you also need people to write the storyboard, you need people to do artistic direction, and so to really validate that those are every bit as much a part of the makerspace as the engineering and the programming.
Always.
Awesome. We have a question about the curriculum that we provide and lesson plans. Just kind of, can you quickly overview how many students does that provide for? Is it something that can be reused with multiple groups? And then how can people find more information about it?
Absolutely. So you can always find more information on our website, edventures.com, and it is absolutely reusable. And the way we package everything is in single modular units. So if you have a really small makerspace, you could buy one set of Discover Robotics and Programming that would come with one robot and one set of curriculum. And then we have packs, maybe a club pack that has 5, or a classroom pack if you want 16. So each one of those curriculums is going to come with one set of student pages. They're printed on this almost indestructible polymer paper. We've spilled coffee on them, tried to rip them. They're designed to be really heavy duty. Your students are pulling these, having them on the table while they're working, and they'll last you for years.
Yep, they're great.
So these student pages are really like we were talking about. They have the projects, they have the core knowledge. So if students are doing programming, it's going to break down, here's how this programming command works, here's how you use it in Cortex, here's a challenge to try it out, and then, okay, here's that design project. What do you want to do? Right,
and you can make these cards work in any space that you have. So for example, they're written so that a student can completely self-guide themselves and self-teach using this curriculum. Now in my makerspace, since we have really knowledgeable instructors, we don't have the students sit down and read that card. We instruct them through those first, for the first couple of cards and give them that fundamental knowledge. And so we've made the curriculum work without having students just read. So it can be used in any sort of space that you have with any sort of instructional level knowledge that you are also working with.
And it's great too because your instructors are constantly learning. So you may have an instructor that says, oh yeah, I've done intro robotics so long. They glance at the card and they say, oh, the student's learning motor commands. I got this, and they'll walk it through with them. But maybe it's their first day in lab and they don't know motor commands yet. They can say, I don't know how this works. Let's take a look and kind of guide the student through that and model that process for them.
A learning environment where the instructor is also learning with the student.
Yeah, that's huge. So again, those come in kind of a set of folders. Each one is for one student or a group of up to 3. Tends to work well for maybe one robot or one set of engineering manipulatives.
Yeah, I encourage people to go online and just see the array of things that we have. Because it's all really dependent on the space that you're working with.
Yeah.
And that's awesome. One other question I think that fits really well into this, talking about the curriculum that we've developed, is how much training is required or ideal for instructors?
Yeah, it's a really good question. We always offer professional development training, so walking you through here's the basic introduction to, say, robotics, here's how the curriculum works, here are some best practices to implement. But it's really designed that if you have, like a lot of maybe boys and girls clubs do, a really enthusiastic staff that's awesome with kids, but maybe has never done robotics before and a little scared, that they'll be fine, because your role is really to be that mentor and that coach.
Like
and if you have a staff that's able to do that, to jump in with kids, the curriculum will take care of the technical, how does this work, what do I need to do, and you can go through it with your students.
Exactly. I have my staff go through the curriculum, and they actually have to pass their badges just like a student, so that they're really knowledgeable about where that information is leading a student. So you can do it that way as well. I actually incentivize my instructors, and they get pay increases for their badges. But I mean, I throw my instructors on floor with my students without a single day of robotics. So it's really wonderful. That curriculum is wonderful for any level, like we said, of instruction.
There is a question about, can you elaborate a little bit on the badges that the students can earn and how that system works? I know it's pretty complicated, but
I wish we had a graphic up of the
Trying
badge.
to go back. We can go to this guy here at least a little bit.
Yeah, something like that. So we have a pyramid system. So a student starts out, actually, their very first day, they do yellow robotics. And that's kind of the foundation of what we do as robotics. And we realize if they learn how to program a little bit and to learn how to run motors, that opens all the doors and windows to whatever other thing they want to work on in lab. Once they complete their projects, challenges, and design project, we mark them off. They have actually a little name badge with their blank pyramid on the back. They color it in, and then they get to choose what they do next. So again, they have to have 2 yellows to have an orange badge. Once they get 3 yellows, they can support 2 oranges on top of that, and then they can support a purple badge. And so you have to have a breadth of knowledge before you can really become an expert in one thing, because all STEM topics are interrelated. And so PCS curriculum actually goes through, the first level that any student will do is yellow. Once they've completed all those challenges and design projects, then they move on to orange, purple, blue, green, red, brown, and then black.
And that's where the karate belt system analogy kind of comes in. So each one of these titles you see here is yellow through blue. So the curriculum, instead of chapters, it's broken down into those levels, like Nikki was saying. So yellow would be like level 1, and then orange, level 2, purple, level 3, blue, level 4. And then for robotics and programming, you can go all the way up through black.
Right.
And it gets into the really advanced sort of programming that challenges even those high school seniors.
Exactly. Yep.
Awesome. Thank you so much. We are out of time today, so if there's any other questions that you have, feel free to just type them into that question box as I'm talking here to wrap up. I get a record of all the questions that you put in there, so I will follow up with you or send out your questions to Nikki or Michelle or one of our SIM specialists in your area. And feel free to, again, if you have something that comes up later, send us an email to sales@edventures.com, and we will respond to that as well. And you can also call us anytime, 800-429-3110, and we're happy to answer those questions you have about Makerspaces, the products that we mentioned with our Makerspaces. I know that some of you are interested in seeing, a list of the curriculum and materials that we mentioned, as well as, that badge system that we have and how that works. So feel free to send us an email or give us a call. Before we leave, I want to announce our winner here. It looks like Jeffrey Johnstonbow is our winner of the 3D Fisher Technic printer. Sorry, Fisher Technic 3D printer. Congratulations. I'll be following up with you, Jeffrey, to get your shipping information and have you sign a little prize acceptance form. Congratulations on that. And thank you everyone for joining us today. We'll hope to see you on our next webinar. Check us out at edventures.com. We will post, our next webinar soon, and hope to see you there.